Hey everybody, today we're looking at lesson 2.6, which is not really a lesson. All we're doing today is we're putting together everything that we've done so far into one document, okay? Putting all of our rules together in one place, all of what our graphs looks like together in one place. This is a great study guide. So what we're going to do is we're going to start with sine. We're going to go through all the information about sine. If at any point you need to pause to write down all of the information, please do so. Okay, and as we go through, please pause if you need to write stuff down. So when we look at our sine function, okay, I'm going to start over here. If I have f of x is a times the sine of b times the quantity x minus h plus k. All right, our amplitude is always the absolute value of a. Our period is 2 pi over b. Our phase shift, if we have x minus h, we're going to shift to the right. If I have x plus h, we're going to shift, that should say left. Okay, that should, guys, everybody make that say left on your paper, not down. My apologies. Okay, our vertical shift, plus k is up, minus k is down. Again, this is left. All right, when I look at my parent function, that is when all of my a, b, h, and k is all 1. Okay, so my parent function is just the sine of x. So when I look at graphing this, I always start with my midline first, and then I look at my amplitudes. Okay, my amplitude here goes up 1 and down 1 because that is my a value. Okay, my period is 2 pi. All right, because that's 2 pi over b. And my increments are going to be 2 pi divided by 4, which is every pi halves. So here, 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 and here. Then we are going to graph it and look and see if we have a phase shift left to right, which we don't. So in this case, we start on the midline. Sine always starts on your midline. If the sign is positive, we're going to go up, then down, or up, then mid, then down, then up. All right, we're using these patterns that are right here. Okay. Our domain is all real numbers. Our range is going to oscillate between -1 and 1. Okay, and again, my period is 2 pi. My amplitude is 1. I do not have any asymptotes. Okay, let's look at cosine. Again, feel free to pause if you ever need to write anything down. Okay, so my parent function is just the cosine of x. Again, range is all reals. Domain is all reals. Range is -1 to 1. I don't have any asymptotes. My amplitude is 1. My period is 2 pi. Everything that is over here is the same as it was for sine, except we're writing cosine. And again, same kind of thing. To graph it, we always start with our midline. Then we're sketching out our lines for our amplitude. Okay, we're going to look and see if we have a phase shift left to right. In this case, I do not. If I did, I would shift it back. All right. If my cosine is high, we're going to start, or is positive, we're going to start at a high point. If my cosine is negative, we would start at a low point. And then we would use the pattern high, mid, high for all of our positive cosines. And if our cosine is negative, again, we start at a low, go to the mid, go to the high, go to the mid, go to the low. All right, for tangent. Our tangent functions are when we start getting those vertical asymptotes. All right, our domain is all real numbers except those multiples of pi over 2. All right, so we're going to go pi over 2 plus pi. So each one of these green lines cannot be a point in our domain because it is an asymptote. Now, please know that I'm not going to stress over domain and range for these next 4 functions. They are kind of a little bit of a challenge. We haven't really talked about them in class. They will not be on your test. All right, domain and range for sine and cosine will absolutely be on your test. But for tangent and the other 3 that we're about to get to, we're not really going to focus on domain and range. But what I do want you just to understand is that there are places where the domain does not exist, or that are numbers that you cannot use because they are asymptotes. All right, and our range for tangent as well as cotangent is all real numbers. All right, so remember, we do not have an amplitude for tangent, and our period is pi. So when I look here, when I look at my standard form of my tangent function, okay, a times the tangent of b times the quantity x minus h plus k. Again, your phase shift and your vertical shift are going to be the exact same as they were for sine and cosine. Minus h shifts to the right, plus h shifts to the left, plus k goes up, minus k goes down. My amplitude, I don't really have an amplitude. However, remember, we use that a value to find where these points go. And my period is pi over b. So the way we graph our tangent line, we start as always at that midline. All right, then I'm going to find out whether or not, first of all, I have a phase shift. If I do have a phase shift, that is where I'm going to put that point that is in the middle of my tangent graph. If I do not have a phase shift, it goes right here at 0, 0. Then I'm going to use that a value to find out how far above and below my midline do I go for these two extra points. All right, so we're always going to use our increments to figure out how far apart these should be. Or remember, we can just say, hey, we're dividing it in half. Okay, once I grab my midpoints here, or my middle points of my tangent function, I'm going to cut those points in half to find my asymptotes and draw those in. Okay, then we use that amplitude to go high and low, and a positive tangent is going to snake upwards towards the right. A negative tangent will snake downwards as it moves to the right. Okay, it'll reflect over the or the x-axis. All right. Cosecant, which is the sine reciprocal. All right, again, with domain and range here, it's not going to be a heavy focus, but we need to understand that everywhere that there's an asymptote, then that domain's x value does not exist. It does not work. My range is going to be everything between, or everything above this point and everything below this point. So I do have an empty space between -1 and 1. All right, and those asymptotes can be found in pi. Again, we don't have an amplitude and our period is 2 pi. So again, when we look at our standard form is a times the cosecant of b times the quantity x minus h plus k. Our amplitude of a we're going to use to graph sine. Our phase and vertical shifts are the same. Our period is 2 pi over b. The easiest way to graph cosecant is to plot the points for your sine graph. Every time your point hits a midline, that is your asymptote. Every time you have a high point, you're going to draw a parabola that opens up. Every time you have a low point, you're going to have a parabola that opens down. The same thing is going to be true for our secant graph, except that we're going to graph cosine instead of sine. So we're going to graph all those cosine points, and everywhere we have a point on the midline, we're going to draw an asymptote. And again, the high points, we draw a parabola that opens up. Low points, we draw a parabola that opens down. Again, we're not going to focus on domain and range, but realize that in our range, we are missing this section in here. It is empty. All right, know that this is the opposite kind of what our domain was, or excuse me, our range was for cosine. My cosine range was -1 to 1. This is everything outside of that, including 1. All right, and then again, our cotangent is going to be graphed almost the same way as our tangent, except instead of starting at our middle point on the graph, we're actually going to start with our asymptotes. Okay, number 1, always first we graph that midline. Then I'm going to look and see if I have a phase shift. Okay, my phase shift, if I do not have one, like I do not here, okay, then that goes on the y-axis at the 0. I'm going to use my period to graph the next one, and the next one after that, and the ones before it as well. Finding my center points by finding the point that is directly in the middle of my two asymptotes on my midline. And then we're using our increments to graph on either side of those. For a positive cotangent, our graph is going to go down as we move from left to right. And for a negative cotangent, it is going to go up as we move from left to right. All right. So again, this is not exactly a lesson. It is just taking everything we've done so far, and we're just going to put it together on all one paper. If you have any questions, let me know. Again, go back, rewind, pause if you need to copy anything else down. All right. I hope you guys have a great day.